We learned that hypotheses are a tentative statement about the relationship between two variables. That is, we're making a prediction about whether one thing is connected to or causes or is related to another thing. For example, most people assume that SAT scores or ACT scores, the standardized tests that you take in high school, are related to your performance later in college. That's why they use them. Presumably, this standardized test is going to tell you how likely someone is to succeed in college. What you might want to do is actually determine mathematically, is a person's SAT scores or ACT scores related to, say, their GPA in the first year of college? Correlations are the technique that we use to determine whether two things are mathematically related. So a correlation, here's the definition. First off, a mathematical measure of the relationship between two variables. As an example, research question that's probably a little bit more applicable and perhaps a little bit more interesting than whether SATs are related to GPA in college, is this. Is political affiliation associated with the use of face masks during the pandemic? And your research question specifically might be, are Republicans less likely to wear a face mask during the COVID-19 pandemic? This might be an intuition that, based on the news you see, based on just generally maybe even people that you know, a conclusion that you would come to. Yeah, I think people who are who identify as Republican, who are maybe more have more conservative politics, are going to be less likely to conform to using a face mask. Again, this might be an intuition you have, a belief that you hold, but we do not know whether it's true unless we actually gather data to demonstrate that it is. So how would we do that? Well, remember, when we come up with a hypothesis or a research question, we need to operationalize our variables. Here, we can operationalize the two variables in this question by looking at, first off, the number of Republicans, so whether someone is Republican, and then we need to determine whether people are wearing face masks. So one way that we could measure this is, say, by measuring the percent of Republicans in the county or within South Carolina counties. Then, if we want to operationalize using a face mask, there are a number of ways that we could do this. One that I think would probably be fairly effective, especially if we're trying to measure the use of face masks within a county, is if we count up the number of face masks seen at Walmart per day. So for example, if you just had someone go out to a Walmart, they stationed themselves there, and they were sitting there with a clipboard, and they just recorded, okay, is this person wearing a face mask? Is this person wearing a face mask? If anyone works at Walmart, I'd actually be curious to hear about this, but I do see people who sit at the entrance, and they do seem to be recording something, and I've always wondered whether the proportion of people who are wearing face masks, that they can have that data about, are people adhering to this requirement or not. Okay, well, let's say that we do that. We're collecting data in that way. So let's say we go into the county records and we look at how people are registered for each election. So we can get the percentage of Republicans within a particular county versus the number of Democrats versus the number of independents, et cetera, et cetera, et cetera. Then we can actually go to a bunch of Walmarts, maybe the most popular Walmart in each county, and start counting up the number of face masks we see. Well, let's say that this is what we find. So we go out, we collect that data. And what I have listed here are 8 different counties from South Carolina. And I didn't go into the county records, but I took kind of a guesstimate, what I thought was true. In reality, you should be going to look up this information yourself, but I don't. These records weren't super readily available, so I just made up the data. Beware of that. None of this is real. So on the left side of this column, we have each of the counties listed: Colleton, Charleston, Beaufort, Orangeburg, et cetera, et cetera. Then we have the percentage of Republicans. So percent of R is a percentage of Republicans. So if a percentage is some proportion out of 100, For example, I'm saying that in Colleton, maybe 80% of the people are registered as Republican, versus in Charleston, 40%, less than half of the people in Charleston are registered as Republican. Now, your intuition about these percentages may differ from mine, but these are some rough guesstimates. I'm going to guess that people from Charleston, on average, are probably a little more liberal, probably more likely to be affiliated with the Democratic Party versus Republican, versus in relatively more rural areas like Orangeburg, Allendale, Colleton, you'll probably see a higher percentage of Republicans. So we have our data listed on the left side there, and on the right side, this is the data we gathered by recording the number of masks that people wore at Walmart in a day. Chances are these numbers will be much higher than this. You get a lot of people going to Walmart per day, but let's just say 100, 300, 275, each corresponding to each county. So that's what we have. What we can do is we can take each of these data points and we can plot them on a graph. And that's what I've done here. So let me orient you to a little bit to this, for those of you who do not easily navigate graphs. At the very bottom, we have that percentage of Republicans by county. So at the very left side, we have 30, because nothing went below 30 in the data that we have. So starting from 30% all the way up to 90%. Then on the left side, we have the number of masks observed at Walmart per day, going from 0 all the way up to 350. I believe the maximum one was 300. So I plotted each of these data points out, where when in Charleston, where I guessed there was 30% Republican, I saw 300 masks per day. Then in Beaufort, where I predicted 50% Republican, they saw 275. And then so forth and so on for Union, Aiken and Sumter, Allendale, Orangeburg, and Colleton. Well, when you start graphing these points out like this, what you can do is you can start to identify trends in the data. Whether one thing seems to change systematically with the other thing. So does the number of Republicans, or the percentage of Republicans in a county, is that related in some way to the number of masks observed? And you can see that I drew a line here, this dotted line in the center. This is the line that you would get from calculating a correlation. You want to see the strength of the relationship between our two variables. And this line right here is evidence that there is. Well, what you're seeing is that as the percentage of Republicans increases per county, the number of masks observed goes down. You guys see that? So as the percentage of Republicans increases, the number of observed masks goes down. So we're seeing that they are related to some degree. We're not sure how strong this relationship is, but given that there is this trend where you have Charleston at the top left, Colleton at the bottom right, and those are the two most different in the percentage of Republicans, that there seems to be a trend here. Well, when we're trying to describe this trend, and we actually take those numbers and we correlate them. I'm not going to ask you guys to calculate correlations, but I will ask you to learn what a correlation coefficient means. So from this data, if we run a correlation, we actually go through the computation, the mathematics of calculating a correlation, at the very end, you're going to get a number. And that number ranges between -1 and +1. So at the very center, there's 0. And if you have a 0, what that means is between those two variables, you saw absolutely no relationship. So if we saw no relationship between percentage of Republicans and number of masks, our graph would have looked like this center graph on the right here, where the dots are spread everywhere. There's no real pattern in how two things are related. The further you get away from 0, the stronger the correlation is going to become. So as we go closer to +1, you'll start to see something like the graph on the top, a perfect positive correlation, where as you move right on the x-axis, so that the bottom axis. In this case, the percentage of Republicans per county, as you move right on that axis, then you would expect an equal change in the number of masks observed. So you'd see the number of masks go up as the percentage of Republicans go up. That would be a positive correlation. Now, what we found is something called a negative correlation. So this would be if that number moves closer to -1 from 0. So as it moves closer to -1, it's still a stronger relationship. But now we're saying that as one score increases, the other one tends to decrease. And that's what we found here. As percentage of Republicans increased, the number of masks decreased. Okay. So we start at 0. 0 means no association. That correlate those two variables, they're not related. Closer to 1, you have a stronger positive correlation, where when one variable increases, the other one also increases. And if it's closer to -1, as one variable increases, the other one decreases. So these are the two things that you can get from a correlation coefficient, from this number. One, it's either going to be positive or negative, and that indicates the direction of the relationship. If it's positive, the two variables change in the same direction. They both go up together, or they both go down together. If they are negative, then as one increases, as one goes up, the other one tends to go down. That's simply what you get from positive or negative. The size of the number, that is the distance from 0, how far that number is away from 0, indicates the strength of the relationship, how closely those dots cluster around. So as you get closer to 0, you'll see something that looks like that center graph, where the dots are kind of spread far apart. And then these graphs on the bottom and the top are perfect correlations. This is what it would look like if it were 1, where the dots perfectly fall on that line that we're drawing. This graph here, this is not a perfect correlation. It's pretty strong, but it's not perfect, because you can see that those dots do not fall perfectly on that line. So what this might be is something like a 0.7 or a 0.8, where it's close to 1, but it's not perfect. But it's not so close to 0 that the dots are all over the place. That's how you get strength from this correlation coefficient. That's what the number means. So it'll be important to differentiate these two things, whether it's positive or negative, and how big the number is, how far the number is away from 0. I want to go through some examples here, all right, because these are kind of the kinds of questions you'll be asked to answer on the exam. If I were to give you two correlation coefficients, R is the letter that we use to refer to a correlation coefficient. So R equals 0.4 or R equals 0.6. Which one of these associations would be stronger? That is, the association between masks and percentage of Republicans is stronger. That is, one tends to predict the other more closely. Well, again, remember that the number, the side, the strength of the relationship is determined by the distance from 0. So which of these numbers is further from 0? 0.6, right? 0.4 is closer to 0. 0.6 is closer to 1. All right. Well, how about this one? Which one is stronger? Again, which one of these numbers is further from 0? The answer here is the negative 0.47. If you got this wrong, you may be following an intuition that you have, that negative numbers are smaller. In a way, you're right. However, again, remember that we're determining the strength of the relationship by the distance from 0. So negative 0.47 is going to be further, it's closer to -1 than 0.36 is to +1. So the strength of the second relationship is stronger. Remember, the strength is going to be determined by how far the number is away from 0. How about this? If I were to ask you this, an r equals -0.49. Does this mean that the variables change in the same direction? So that is, as one increases, the other one increases? Or as one decreases, the other one decreases as well? Or does it mean that the variables change in the opposite direction? As one increases, the other one decreases? This is what you should be paying attention to here is not the number, but the sign in front of that number. Remember, the difference between a positive and negative correlation, that plus sign or the minus sign, is going to determine the direction of the relationship. So in this case, a negative is going to mean that the variables change in the opposite direction. As one goes up, the other one goes down. As the number of masks worn increases, we tend to see a lower percentage of Republicans in that county. So likewise, this one, r equals 0.8. Again, we are ignoring the number itself, and we are looking specifically at whether it's a positive or negative value. In this case, it's positive, so the variables are going to change in the same direction. As SAT scores go up, GPA in college tends to also go up. And that is the relationship that you see between SAT scores and GPA, your grade point average. Look through these examples again before the exam. I assure you there will be questions on the exam about this. Okay, so what can we infer from a correlation? What does a correlation really tell us? Why are we doing this in the first place? Well, we know that it helps us determine whether two variables are related, but there is something that it doesn't tell us, and this is very, very important to realize. Here is a correlation, it looks a little bit different than the one that I drew before, between divorce and sales of margarine. So those of you that don't know what margarine is, it is a butter substitute made out of vegetable oil. So margarine used to be a big craze back in the day, like 20 years ago. When I was a kid, my parents loved buying margarine. They thought it was healthier. I don't believe there's good evidence of that compared to butter anyway. Anyway, if you look at the rates of divorce within Maine, so this data was taken from Maine, the state of Maine. If you looked at the rate of divorce in Maine and then you compared it to the amount of margarine that was sold within the state from the years 2000, so looking at the graph, it goes from 2000 to 2009, these two things were correlated such that as divorce rates decreased from 2000 to 2005, margarine sales also decreased. And they continued to be associated up until about 2009. And chances are, if you look at this data still, they'd probably be correlated to some degree. Well, what does that tell us about divorce and margarine? Is divorce driving margarine sales, or is margarine driving divorce? So if your family buys margarine, is that family going to be more likely to experience a divorce in their lifetime? No, they're not. Again, what you can get from a correlation is that two things are related, that they tend to go hand in hand. But one thing you can't infer is something called causation. You don't know that if two things are correlated, you don't know that one causes the other. So if we go back to our example of face masks, we might be able to say that within certain counties, as people identify as Republican more, they are less likely to wear a mask. But that doesn't tell us that if you are Republican, that is causing you to not wear a mask. Likewise, we can't say that if you are not wearing a mask, that you are somehow driven to be a Republican, right? So again, we can't infer causation from this, from a correlation. So the advantage of a correlation is that it's useful for identifying patterns. We simply want to know whether two things are related. The other advantage of a correlation is that it's cheap and easy. It's usually very easy to collect data that you can then correlate. A correlation is a very simple mathematical procedure to carry out compared to some of the other things that you can do. The disadvantage, though, is that you can't infer causation. So does buying margarine cause divorce? No, there doesn't seem to be strong evidence for that. Couldn't even reason my way towards that. Perhaps you could say, oh, people who don't get butter in their lives, who are not having that pleasure of having that natural butter, are just more dissatisfied. They're more angry people, and so they end up getting divorced more. But I don't think there's evidence of that. Not that I've seen, though I'd be open to changing my belief with evidence. The other thing that's important is you can't infer directionality. And I want to give you a slightly different example for this. So if you look at the data, if you look at raw numbers and you compare political affiliation, Republican, Democrat, and you compare intelligence. We measure intelligence using something called IQ, which I'll probably explain a little bit later, but for now just know that it is it's a standard way of measuring intelligence. If you look at the association between political affiliation and intelligence, it turns out people who affiliate with the Democratic Party tend to be more intelligent. They score higher on these IQ tests compared to people who identify as Republican. Now, again, we can't infer causation. There may be nothing about why, there may be nothing about being a Republican that makes you less intelligent, or anything about being a Democrat that makes you more intelligent. The other thing we can't infer is, so what's driving this? Let's say that this association were true, that one is causing the other. We can't conclude, so we have two possibilities. Either political affiliation is making you more intelligent, so that is when you join the party, by virtue of being part of that party, it's making you more intelligent. Or the opposite could be true. Does being more intelligent in the first place make you more likely to adopt certain political beliefs? It could go in either direction. We can't infer that, though. We don't know whether one causes, or whether political affiliation causes a greater intelligence, or greater intelligence causes which party you tend to affiliate with. We can't know that from a correlation. Okay, so correlations are really cool, but they don't really get at what we really want to know. And that is, okay, it's fine that political affiliation is associated with mask use, but we really want to know whether political affiliation is causing that mask use. Or more importantly, the bigger question is, do masks actually prevent the spread of COVID? This is something that you sample a bunch of people now. I imagine people are coming around to the conclusion that they do, but there are plenty of people who doubt that face masks prevent the spread of this virus. Well, if we were to run a correlation, we could show, oh yeah, as you wear more masks, you see less spread. But if it's a correlation, we can't conclude that masks actually cause or prevent the spread of COVID. We can't infer causation. So how do we figure that out? That's going to be the topic of our next lecture.